Today we're going to talk about epigenetics, okay? Epigenetics. What does epigenetics mean? Epigenetic means, number one, you have genes, then you have epigenes. So genes really speaks about what we have to help us carry forward a lot of hereditary information, and it talks about sequences, A, B, C, that's the sequence. Whereas epigenetic looks at how we express those genes, not how we change around the genes. So epigenetics really is a study of how we can express our genes either negatively or positively. Whereas genes, you just get it from your mom or your dad and you pass it down to your family. And so with that in mind, we look at the sequence will be the same with normal genetics, but when you deal with epigenetics, you're looking at the same sequence, the same order, however, you express the gene differently. So an example would be maternal nutrition, malnutrition, drugs, a poor diet, poor exercise habits, or chemical insults, exposure to certain kind of chemicals. So the important thing here is knowing that with epigenetics, you can have what we call transgenerational expression. What does that mean? Big term. So if a mother is smoking, she herself, she'll have a very, very different expression of certain types of genes in her own body that can make her cells become cancerous as we know it, right? Lung cancer, skin cancer, lots of kinds of cancer, womb cancer, cervical cancer. But not just that, also the baby in her tummy, that baby can also have those expressions in their genes of those unlocking of cancerous genes. And here comes the frightening part. The baby that's in her tummy, the gametes or the reproductive organs of that baby has also been changed. So that's 3 generations just in one. So one person having an effect on their body like smoking, that's just an example, affects the baby but also affects the womb of the baby, which means that the grandchild of that mother, the grandchild, will have the risk of cancer because of what grandma did. So that's very, very, very important for us to know. The same we found out for infections, viral infections, like with influenza. And now that we have coronavirus, this is interesting. No one has looked at this, but the studies in the past have seen that mothers who have an altered immune response in their body because of exposure to toxins like smoking, they're more likely to have influenza. Also, their babies are likely to have more influenza. And guess what? Their grandchildren are also most likely to have influenza. So they have altered immunity because of cancerous expression in certain kinds of genes, which means then that probably some of the COVID that we're seeing going around has been programmed long before now, which is very interesting. So why are we talking about that? And this is to do with our everyday health. So whenever we look at genes, we look at how can you modify genes. And one of the ways of modifying genes, there are 3 ways of doing it, is by what we call histone modification, or by microRNA, or also by methylation. The common one that everyone talks about nowadays is methylation. So what does methylation mean? It means that you put a specific chemical group on top of a gene, and then you actually change the way the gene will act. So how does it affect us? Did you know that by eating broccoli, you can methylate your gene? So broccoli itself has specific chemicals. This is just one example I'm giving you. It has specific chemicals in there that causes increased methylation of our genes and locks off certain cancerous expressions of genes. Does not change your genes. What does it do? It changes the expression of the gene. So there's a way that you can turn on a gene or turn off a gene just by the way you eat. Another example is carotenoids, which you find in like carrots, right? Anything that has a lot of color in there, in our vegetables. They are known specifically to turn off cancerous type genes.